What is up, people? How's it going? I'll start in about a minute's time, so wait for some people to join and we can get moving on. I'm not sure how many people are live right now because the numbers are not showing for me, but um, let me see. Yeah, okay, I'm doing fine. Yeah, just tell me, guys, if my audio isn't fine. Looks like it is fine, but if it isn't fine, just let me know so that I'll know for sure and I can make some changes. There's another live today as well, and in the evening, so if you guys are free around that time, join that as well. Yeah. Anyway, so yesterday session is basically looked into the concept of type defs and callable classes. For this one, I'm going to be talking about isolates and what exactly are isolates and why are they very useful. And why do you need to know about isolates in the first place? And that's what we're going to be covering in today's session. So just before even we begin, I just want to make sure that some people are there to watch this first of all. But on the other hand, I also want to make sure that there are questions that is coming in back and forth, and that's going to be very helpful for us to move on, right? So let me check. Yeah, I guess I'm going to give another minute or so so that it does get interesting. I understand it's 11:36 in the morning on a Sunday, and yeah. All right, so I'm going to share my screen, and we're just going to get moving on from here on as usual. All right, so there I am. So what I'm going to do is in this session understand what are isolates and why do you need to know about isolates in the first place. And it is not like these are some new concept, but in Dart it definitely is. And why do you need to know that in the first place is because Flutter as a toolkit is completely dependent on the concept of isolates, and isolates are very important. I did give a brief about what these are in yesterday's session. So as you can see here, we talked about parallelism, thread, and all of that sort. And we're going to be doing that as well again here, but we're going to be doing in depth about that and trying to understand as much information as possible. So the first information or the first word that I'm going to be trying your writing here is the word threading, right? And let's hear from you guys, like what exactly or how exactly or how many of you guys know about threading. Threading is the concept of giving shared memory and shared CPU so you can do a work much faster. So a core of a CPU, like let's say there's an 8 core CPU that you have, right? And the 8 core CPU, each of these cores can spin multiple threads. And these threads, as the name suggests, you can think of them as thread that you put in a needle. And each of these threads have access to the same memory, have the access to the same CPU, and they can do a simple task in 8 or probably how many threads how many ever threads that you spawn, and they can do these many number of tasks in these individual threads. So technically these are actually splitting the same work, and at the same time these are actually using the shared memory as well as the shared CPU. They're sharing the CPU as well as the memory, and that's the most important part of a thread. And this threading is very important concept. This is very useful when you're trying to build a framework that is time dependent. I also gave an interesting example in like last week's session where we talked about a Tesla car, right? The Tesla car is running here, and we have the Tesla right here. The Tesla car is going to be running, and it's actually supposed to be doing all these sorts of computation in split second. It pretty much needs to do it in a blink of an eye. That's how we react, right? As a driver, we react in probably point 0, probably point 0.01, point 0.04. I'm not really sure of the number, but let's say that you react in one tenth of a second. So you need to react in one tenth of a second to something that requires huge computation. It needs to check the size, it needs to check here, it needs to check the front, it check the back, and you also need to check all the long distance things and then compute where you want to go. There's a car that is parked right here. I need to go around it, right? And this is doing that many computation in probably 0.1 second. And this is probably what requires, like, let's say that everything you are going to run is going to be in a single way. You are doing everything one after another. This is not going to be possible. It needs to run parallelly, so that everything runs in it runs almost in parallel, and it is trying to do all the computation in parallel, and that's how it is trying to understand where the car has to go. So that's how the concept of threading comes into picture, even though you cannot pretty much say that Tesla is using a lot of threads or anything of that sort. But at the core of this, the whole idea behind parallelism and threading is to reduce the time that it takes to run a program. And if you see in most of the popular programming languages like Python and Java and C++ and all of that sort, these programming languages rely on the traditional way of threading and parallelism. Python, Java, and C++, right? All these three, not just all the three, any of the programming or the traditional programming languages that you've seen so far, that is there so far, relying on the concept of threading and parallelism. Threading is one concept and parallelism completely another concept. So let's assume that both of them are trying to reduce the time of a program. So this is going to be the whole idea behind the parallelism and threading, right? But in Dart, right, in Dart it's completely different. There is no concept of threading or parallelism in Dart, and there's a new concept called as isolates, right? These isolates are completely responsible for doing everything and anything, and pretty much doing everything that is possible to run something in asynchronous fashion. So everything that you're seeing as part of your async, await, all of that sort is supposed to be running in something called as isolates. Asynchronous fashion is completely possible with the help of isolates, and that's the whole thing that you are supposed to be learning. One of the most important ideas behind this isolates, or what the need for this isolates, was to reduce the amount of memory that gets used was to reduce the amount of memory that gets used when you're trying to use threading or parallelism. Like I said, in threading, you either have access to the same memory, basically sharing the memory space, and you're sharing the CPU space. And in order to reduce that, or in order to give some other way of running things in asynchronous fashion, they came with the concept of isolates, and that's what we're going to be learning about in this session. So I'm just going to wait another minute or two to see how many people are going to be joining, and we can get moving on from there. All right, so hopefully you guys did understand about threading and parallelism. I just give a quick intro into what these are and what isolates does on the other hand. Now, isolates are similar concept, but on the other hand, it is having something completely different. The compiler is completely using it differently when it comes to the Dart programming language. You don't have to necessarily know the Dart programming language to understand isolates. Even though you're going to be doing some kind of a code in this session, you're going to be learning to write some code, but the isolates are completely new, and you can expect them a lot more in the upcoming programming language sphere, right? Since isolates, the whole idea behind isolates is to use as same memory heap. The same memory heap is actually a huge time saver. It actually reduces the time that it takes, and it actually uses the same memory heap. So I'm just going to be looking or doing a simple, I'm going to be sharing a slide in about a minute's time. So let's get hearing from you guys, like, as to what exactly do you know till now? Do you know about parallelism? Do you know about threading already? If you do know, just let me know so that I can get a better understanding of what I need to deliver. So yeah, let's hear from you guys. Do you guys know about threading? Do you guys know about parallelism? And I'll talk about that probably in another minute's time, right? So it's time for questions. I'll open for questions. So let me know what you guys want to know about. Let's clear the frame and put the big questions here. So we talked about parallelism, we talked about threading, and we just now said these two things are engulfed by the concept of isolates. And the whole idea behind isolates is to use the same memory heap instead of a shared memory heap. And I'll tell you what the importance of that is in about the next slide. So if you have any questions, just let me know right now so that we can get moving on and we do not break the flow. And if you don't, I'll get moving on in about a minute's time. All right, I'm back and we're going to be moving on. So the first slide that I really wanted to show is this slide right here. So what exactly are isolates? So like I mentioned here, most computers, especially on mobile platforms, and not just on mobile platforms, on any platform, have multi-cores, right? And pretty much whatever you are seeing right now, all the phones that you have, all the phones that you are using have multi-cores. And when I say multi-core, it means that it is able to handle multiple different information in much faster sense than it used to do previously. The whole idea behind smartphones have to be because of the improvement in the processor and the improvement in the process chips and how fast these chipsets are running. So to take full advantage of this course, developers traditionally use the shared memory threads to run concurrently. So when I say concurrently, that exactly means that you need to do everything in a synchronous fashion, right? Nothing synchronous is happening, it's running almost in parallel. And shared state concurrency is error prone, and this is what I mentioned when I said about doing things in a shared fashion. If you have a shared memory, that means that you are trying to give lot of information between threads, and it could be error prone, right? Like this is one of the most important issues when it comes to parallelism and threading, and it's still not solved. You have the concept of deadlocks in when you're trying to talk about threads, right? When you talk about threads, you talk about deadlock. What does this deadlock mean? The deadlock means that two threads trying to access the same memory. There's a two threads running, and these are trying to access the same memory, but this thread has to do it, so this has to wait. So when you're trying to access this thread, this has to wait, right? What happens is that this thread is never released, and this thread is waiting forever. So this is going to be in a deadlock situation, and this is what we are trying to avoid. And since this is a shared memory model, everything is trying to access the same memory. It is kind of like getting into the deadlock state. But in order to avoid this, what you can do is to probably split a shared memory. Let's say this is actually a 3 MB memory, and what you can do is to split this 3 MB into 1.5 and 1.5, right? And give each of these threads one memory to store this information. And that's exactly what the concept of isolates are doing. So even though this might take a little bit of extra effort from the compiler to do so, like split a 3 MB memory into 1.5 1.5 and give each of these 1.5 memories into to a specific thread, you do find that it is very difficult. I mean, in terms of the compiler doing it, but in the longer run, you're avoiding the whole problem of deadlock. And that's exactly what I've mentioned here as well. So in order to reduce the shared state concurrency issue, which is extremely error prone, this is actually going to also lead to a lot of issues when you're trying to build your program. You're trying to make sure this deadlock does not happen. You're trying to have all sorts of fallback scenarios to ensure that this does not happen, and you're trying to do everything you can in order to prevent that. But with isolates, you don't have to worry about anything of that sort. Anything that you're trying to do asynchronously, the compiler is smarter enough to understand that you need to put it in a same state memory, meaning that every thread or every isolate gets its own memory, and that's what is making it extremely useful. So also that's what I've mentioned, the second point, where instead of threads, all dart code runs inside of isolates. So why I mentioned is it as inside of isolates. So when I say inside of isolates, you have a program that is, for example, like 150 lines. Let's say you have 150 lines of code. What happens is that instead of it running on the CPU first, this entire 150 lines of code, the compiler takes it and puts it into this this small isolate. The small isolate has its access to CPU and also access to the memory unit, and this memory unit is basically what is trying to control whole um, your whole isolate, right? So this is every code that you run, every program that you run is pretty much going inside the isolate, and from there on only it is trying to run the whole program. So that's whole idea behind isolates, and that's what we are going to be looking into in a second slide as well, like digging deeper into it. So the program is here, you have 150 lines of code, and this is going inside it, and it now has access to the CPU. Whatever you want to do, it's able to do it, and there's a memory unit right here, and it is also doing that pretty much. This is going to be 1.5 MB. Let's say it's initially assigning 1.5 MB, and it is trying to run this 150 lines of code. And that's the whole idea behind isolates. That's why I mentioned it as running inside isolates, right? All the programs are running inside of isolates, and when I say inside of, that is not what the compiler is doing basically, but it's just the technical term to make you understand that the CPU is little bit CPU. Even though the CPU is available, it is specific to that isolate only. And also, like I've also mentioned at that point, each isolate has its own memory heap, ensuring that no isolate state is accessible from any other isolate. So that means that you are specifically stopping any kind of memory mismatch, memory leakage. All of that is by default stopped without having to worry about anything that is actually might happen or might cause problems in the future, right? That's the whole idea behind isolate. So memory heap is present, no isolate state is accessible from any other isolate. So individual, you can think of them as individual building blocks. Everything is present separately, and all the information inside is for that isolate only. That is, it's isolated. That's the whole idea behind it. So it's isolated from any other block of isolate, and you're not going to be transferring or accessing any other information. You can still send messages and transfer messages between isolates, but you can't go and access the data, that is, or the access the memory of the other isolate. So that's the whole idea behind isolates. I'm going to be showing you a simple diagram here, and this is a very useful diagram as well. This is taken from the dart board itself, like that dart documentation itself. And this is the whole information that you need to know, especially about isolates, right? No shared memory, right? That's the first important part. No shared memory. Each isolate has its own memory, and you don't have to worry about it. So this is going to be the memory, right? And this is where the program is running. Basically, this is how you can think of it. And each isolates can message other isolates. That's what I said, like normal function, and just like, but you cannot in terms of accessing the memory, right? So this is going to be the memory unit here, and you cannot access the memory as such from this point to this point, this point to this point, but you can still send message from one to another. And that's what we're going to be seeing as a part of a code example that I will show in another 5 to 10 minutes time. So the whole idea behind this is to understand what exactly these isolates are. Like I mentioned, it's isolated. Every block is isolated. It has its own CPU, it has its own memory. And what exactly is the use of this, right? And the whole use of this is to improve the asynchronicity. It is going to be improving the speed with which a program runs. And that is a very pretty famous, it's the only thing that is powering the Flutter toolkit. And if you are interested in learning Flutter, you should pretty much learn a little bit about Dart and how it works as well. So we already done a lot of videos on Flutter. We have done a lot of live building with Flutter. So it's important to understand that how the Dart works in the background. So the first thing it does is to, let's say, the Flutter application right here. There's a Flutter application is a UI toolkit for building mobile application. So you have a block here, you have a button here, you have another block here, and you have some images present here. So each of these things are going to be running in isolate, and these isolates are pretty much what is going to be the building block of showing you a mobile application. And that's what you got to definitely know about when it comes to Dart and Flutter. So that's what we learned as well, right? So if you guys have any questions, just drop right now. So we have totally so far seen what exactly are isolates, what is same, and what is shared memory heap, and also learned about the life cycle pretty much of an isolate, like how isolates do work in particular with Dart, and how this improves parallelism and threading in a different dynamic. Threading and parallelism is very traditional. Every time you learn about threading and parallelism, it's always about data being shared, CPU being shared. But with isolate, it's not so. It's completely different. You are giving each of these information specific to one isolate, right? You have a same memory, you have a same CPU, and the isolate or the line of code that you've written is basically running within that isolate. And that's what I show this diagram for. And yeah, so if you guys any questions, just drop it right now so I do know about it, and we can get moving on to the next slide. And I'll be showing you guys the exact use case of an isolate and what exactly do these isolates really do. Just a drop comment and I'll definitely know for sure. Out of the many that are watching the stream right now, so how many of you guys have already have experience with building anything, right? Like, have you guys watched the stream before, or have you guys learned any specific programming language? So if you let me know about that, I can probably give a comparison of sorts, right? Do you guys have any experience learning Python, Java, C++, C, or JavaScript, or any of these languages that are pretty popular? Alright, I guess I gotta get moving, and I'm pretty sure all of you guys are watching this stream for sure. So let's get moving on, because like so far I've seen or told about isolates and how these done, and how you can understand or do much better parallelism compared to what the traditional languages like Java and Python do. And hopefully there is no questions so far, and if there aren't any questions, I can get moving on. But also one of the important point that I also wanted to show is I'm going to be showing a code example as to what exactly do these things do. But the next slide is going to be how an isolate can communicate with another isolate. So in order to think of this, right, in order to visualize this in a much better fashion, think of these in think of these isolates as your Lego block. You have a Lego block that is present, and this is also the same example that I give for Flutter as well. Think of these each isolate as a Lego block. Now you guys know Legos, right? Like it is the building blocks that kind of like you put everything on top of it, you build things on top of it. So think of these individual isolates as a Lego block, and individual isolates are pretty, for example, let's say it's running 10 lines of code only. It's pretty much doing that in asynchronous fashion. So you have another isolate, another Lego block that is present, there's another Lego block present here, there's another Lego block present here. And if you see the Lego block, each of this has its own base and the pointer on top to either take things on top of it or attach things on the bottom of it, right? That's exactly how an isolate works. Even though it is just going to be running 10 lines of code, the Lego block has the mechanism to go attach with another, like my voice is very low, really. I don't get this, but now is it better? I hope now it's better because I'm very close to the mic. Let me check it once again. Hopefully this is better. Let me find a setting. Audio. Check. Is it better now? Or is it better now? But I don't think this is better. I think this is only better. All right. I hope this is better. So let's get moving on. Right. Yeah. Great. So what I was talking about was these Lego blocks, right? You have a building block, you have Lego block, and you want to build like say a house. And each of these Lego blocks has its own like a pointer on top of it to get attached to some other Lego block, or it has a mechanism to get attached with other Lego blocks on the bottom of it, right? So this is exactly how an isolate also works. It has its own CPU, it has its own CPU allocation, it has its own memory allocation, and it can get attached to any other isolate just like that. You can transfer information from here to here, you can get information from here to here, just like a normal Lego block. And when you put all of these Lego blocks together, that's when you have your whole program. So you need to think about it, you need to visualize it in this fashion: a huge program that is like the huge application. You can either think of it as a Dart application or a Flutter application, because at one point you need to like think about it as a Flutter application as well, because without Dart and without Flutter you cannot build any mobile application. There's a huge Flutter application, right? And there is a top heading present, and there's a center screen present, there's a button here, and there's also a bottom present. All of this cannot be put together until each one of them are running in a individual isolate, and all of these are kind of getting attached to one below the other. So the compiler, this Dart compiler, which is running something called as a just-in-time compilation, and also the ahead of time compilation, is smarter enough to do that. And as soon as it completes doing that, there you go, you have all the isolates getting stuck to one another, and the final application is present right before your eyes. And this is a very interesting thing to do, and this has never been done before, right? The Python does not do it, Java does not do it. And why specifically does Dart do it? Because the Dart's compiler is completely written from ground up, and the compilation is completely different. It's not doing the usual compilation that you do in Python or in Java. You take a code, you convert it into a class file, the class file is finally run into a program. That's not how it works. The compilation run as soon as you start writing the program, and that's how the whole idea of the Flutter's hot reload and the application time being reduced is all coming into picture. So that's another interesting one to look into. I'll probably obviously be seeing a lot more videos on that, and I'll try to schedule as many sessions around that as well. So that's how you visualize this whole idea behind, right? That's how you visualize this whole the whole idea being isolates. So let's get moving on to the third slide. So this is another important one. So you talked about isolates. It's fine, cool, everything's cool. But how exactly is the compiler running this 10 lines of code that you talked about right here? So how exactly is the compiler doing it? The first information that you need to do or need to know is the concept of event loop. Now, the isolate has information inside it, but how does the compiler know that each of these isolates have information inside it? So basically what it happens in the background is to think of this as a cycle right here, or like a cycle gear right here, and each of these are basically events. So you can think of this as asynchronous event 1, asynchronous event 2, asynchronous event 3, and this event loop is basically just looking into this queue and just executing every queue, and does not matter what fashion it comes into or what order it comes into. It just executes it, doesn't care where it comes from. So that's why I told here, just think of this as a Lego block, and if this Lego block has this huge, you have built this huge house and there's one Lego block on top, and you keep removing one after another, right? That's exactly what the event loop is doing. So event loop is trying to execute, doesn't matter which isolate it's coming from, but as long as it comes from and the compiler reaches or reads it, it's executing it and just pushing it out. And that's the whole idea behind event loop. And you need to know about isolates and how isolate stores information to understand how this event loop works. So the loop of events pulling, so loop of events getting pulled, I should have written as getting pulled from a queue and processing it without stopping. This is a key word here. It doesn't stop at all unless there is a forceful stop. It doesn't stop at all. So let's see again here. So you have huge, this is going to be your first isolate, and you have memory unit here, and that's what is present here, and you have pretty much 10 lines of code, right? And you have this event loop present for individual isolates, and the compiler is giving information saying that executed. The compiler is like giving a go ahead, executed, and as soon as it gets the compiler says execute, the event loop starts spinning. So it basically spins like this, and the first spinning, it takes the first line of code and sees it, executes it. It uses the memory from here, executes it, again spins, it takes this information, keeps on spinning until all the code is done or there is no more things to be done, and it never stops. It's basically like dequeuing the entire queue. Doesn't matter which order things comes into here, it just dequeues it. And as you guys know, a queue has two ways of dequeuing. One is first in first out or last in first out, and this one is basically doing a first in first out. So whatever came in first, it's getting executed first. So it's actually executing it in a FIFO fashion, right? First in and first out. So hopefully you guys do understand or know about it. If you don't know about it, just drop a comment so I'll know about. I can explain it in depth. So the event loop is looking into individual event 1, event 2, and pretty much running everything from there, and it doesn't stop at all until there is a forceful stop that is being executed by one of these events. If this one of these events says like 15 seconds wait time, just wait for 15 seconds until there's a forceful stop. This event loop does not stop at all. This is basically like looping around and just running all the information and all the code. So that's the whole idea behind event loop, and event loops are very useful, and it's the backbone for an isolate. We do know that it isolates have access to this given like a same memory unit, and there's also access to the CPU. But who connects that, right? Who connects this CPU and the event and the memory, and who does that? The event loop does it. And event loop is basically individual for each isolate. So each isolate has its own event loop and is running all these lines of code by itself, and that's also a very important point. All right, so let's move to the next one. I have another one more slide. Yeah, I'm going to be explaining a code in code example in about a minute's time, and hopefully that you guys did understand in depth about what is happening right now. If you don't, just drop a comment so I'll know for sure. I'll be explaining a code of how you can communicate with how you can communicate from one isolate to another, and it's going to be very very useful, but not very mandatory to completely understand the code as well, because I just want to show that it is possible, uh, even though Dart and asynchronous activities are running in the background. You don't necessarily have to know what is happening, because unless you are digging deep into Flutter and writing something on a compiler side of Flutter, you necessarily don't have to do much of this. But it's a very important concept if you're trying to build your own program with Dart in the future. So we're going to be having a session today at 7:38 about Dart and server-side scripting, and because a lot of you guys did ask about it, so server-side, I'm going to be talking about it today. So if you guys are interested, you check that out. In that session, I'll probably talk about few additional things that are possible and how you can do some processing in the background, and all of that is possible, especially with isolates and asynchronicity that I already talked about so far. So I'll talk about that, but let me take another quick 1 minute break and come back and show you guys how exactly a Dart communication works, like how exactly you can communicate from one isolate to another isolate with a simple 10 line or 20 line code. So I'll do that and let's come back in minutes time. So if you guys have any questions, just drop them right now. I'll probably put it right here. If you guys have any questions, just drop them right here. So questions, just drop them. I'll come back and answer that. Right. So let me take a minute break. All right, so I'm back, and we're going to be doing the next part of this part of the session. So I'm going to be showing you guys a code. I'm just going to be running this code in about a minute's time. I'll probably be running it on the Dart pad, and you guys don't have to necessarily know in depth about it or anything of that sort, and I haven't tried much of this as well, so it's not like I have run this or anything of that sort. I'm just going to be writing, probably I've written this code and I'm just going to be like trying to see how it performs, right? So let me do that right now, and we will see how this code is going to be very useful, right? How this code and makes us understand how isolate is getting communicated, how you can communicate from one isolate to another. So I'll do that right now. All right, in the meantime, if you guys have any questions, just drop them so I do know for sure. Yeah. Hmm. So what we need is all right, so pretty much good so far, it's working pretty fine. So I'll just remove for the SDE auto print. Yeah, you have another section to write, which is so you have a start, you have stop, and what else do you need? You have start, you have a run timer, and a stop and async, right? Or async, yeah, and async kind of main function. So which is what I'm going to be doing right now. Where stop, and you have a print, and you have a print, and you have another print right here. Let's try running this right now. Alright, so I guess this is going to be a problem, but let's see, let's find out, right? Let's see how. Let's just see it here. Hmm. Alright, so I'm going to be not doing anything right now because hi Sanjay Singh, yeah, how can you use native functionality in Flutter? Good question. So there is actually a package that is doing this at this point of time. So if you talk about a native functionality, right? Let's say you want to change something in Android specifically. Um, what you do is you open the package. As soon as you create your Flutter code, and you will see that there's an Android package created, there is an iOS package created. And what you do is you go specifically inside the Android package, and you will find all the .kt files, which is the Kotlin files. And you should have a little bit of understanding with Kotlin. If you want, you can even switch it to Java Android manifest, which is XML. So you need to have that bit of understanding to make changes to this Android package. So what you do is you go to your project, which is what you see after you run first time compile your Flutter code. You see this big project, right? And the side you see that it has two sections. So one is for Android and one is for iOS, wherein you open it, it'll open into a normal Android like project. And inside this you will have all the app, you have the bundle, you have the manifest, and everything present as usual, like you see in a Kotlin file. And this kt file, you can make changes for it to reflect specifically only for Android based devices. And similarly, if you know iOS and you know little bit of native iOS programming, you can make changes to the iOS files as well, and will make changes to only the iOS application and not both Android and iOS. So that's how you make or change, or you can directly change activities which you want. But let's say you want to touch specifically of an Android within Flutter. From Flutter you want to do it, but if you want to do that, that's not possible at all. And that's why in one of my if you look at my channel, there's a very popular video where I talk about why Flutter alone is not important. If you learn Flutter, it's great. You learn Flutter is amazing, but learning Flutter alone is not important. You should also learn either Android or the iOS for native support. If you want some kind of a native support for your application, let's say that you want specifically things to do in Android but not to do in an iOS. One of the most famous application for that is the NFC, right? You have the NFC tag that is running in Android and iOS, and this NFC is completely different functionality for both Android and iOS, and there is no one place fix for it within Flutter. So what you will do is you will open your Android package, you make changes inside it, you make your iOS changes inside it, and then you compile the code for both Android as well as iOS. If there's no package available, like detecting incoming calls when app is closed. What app are you talking about? I don't think there is any package so far. To my knowledge, there is no package that can do this. You can do it because the iOS's call package is completely different compared to what Android or Android stack does, or Android handles calls. So you have to look into a Flutter package that can do that. So one example, what you can do, I hope you did look into the pubdev where all the Flutter plugins are actually going. Oh, like Truecaller. Okay, like Truecaller, yeah, I don't think there is anything like that. Let me check for you. So pubdev, go inside pubdev and open the dart packages, and you can check, right, like Truecaller. Just put Truecaller. Let's see how something comes. There is actually a Truecaller SDK present. So if you want to use that, you can use that. There's a Flutter Truecaller SDK present. You can use that, but yeah, pretty much here. You can use this if you want to, but if you don't want to do that, you can just check into all the available Flutter plugins, right? Call tracker. Just put call tracker. I don't see any packages for specifically tracking calls. Nah, I don't see much. But there is a Flutter Truecaller SDK. Yeah, I don't see anything like that. So that's what you get to do. What purpose? Login? Yeah, that's why, like I said, you pretty much won't have all these Flutter plugins pretty much because the Android and the iOS handles calls differently. Yeah, like I said, you need to check if that is available. If it is not available, it has to go native only, meaning you need to make changes to the Android code as well as the iOS code. Without that, you cannot have access to what you are specifically saying. So if you say that Flutter Truecaller is only for login purpose, then you need to make changes to the Android code as well as iOS code. Since I haven't seen anything so far like that, and there's one package called call might be useful for you, but again it is specific to just reading the contact information and not specifically understand how the call comes into an application, right? And you definitely have to have access to the native code, because Android's calling stack is completely different from how iOS handles calls. So you need to have a different way to do it. If you are really interested to build this, you can even build your own Flutter plugin and release it for other people to use it. But at this state, I don't see anything that is available. So hopefully that did answer your question. Yeah, I got your question. I got your point. So I'm going to get moving on pretty much, because I said I will show a code example for the isolate, but looks like the SDK that is running on the web browser is not going to support isolate execution. So I'm going to drop a link to one of the places where the code is available, which is part of the that document itself. You can check it out, and there's actually a lot of useful things that you can pretty much find inside it. So, and this is going to be the dart location, this is going to be the dart API, where you can take a look into, and you will find a lot of information inside it. And this is also another important way of understanding how darts isolates work. So pretty much that's it for what I was planned for this session. I'll take any questions so far that you guys have. And what also we can look into is how well this can be used for. Like I said, in today's session at 4:30, I'm going to be doing the dart server side. So we're going to be discussing how much of dart server side is possible, and in that session I'll talk about an asynchronous way of loading things in the background, meaning that you have background task running, background processing, background passing, and all these things are going to be possible in that session. So in today's session, which is going to be at um, 8 p.m, so check me out today as well. So you guys are interested, you can dig deeper, and I'm going to be bringing out few more sessions around parallelism, threading, and we're going to be looking into all of that. So let me see you guys in that session. Hopefully the session was informative. I'll figure out now that I'll probably coming out with the entire week schedule in probably a day's time, so you can figure out and see me there as well. So hopefully the session was informative. We learned a little bit about isolates and how these are pretty much useful for I think for understanding threading and parallelism, and completely different from threading and parallelism, but still very useful for when you're trying to build something from scratch. So that's pretty much it for me guys. So hopefully you guys did like this session. Let me know in the comment section as well. As usual, like I say, check me out on YouTube. I have been talking about Flutter. I've been talking about Dart for more than 2.5 years now. So check me out at Coder Monk. That is my YouTube handle, and you can also check me out on Unacademy platform as Baradwaj. Right, my full name is Baradwaj, so it's with a D here. So check me out on Unacademy platform as well as on YouTube. I'll see you guys in the next session, which is at 8 o'clock today. Until then, it's Bharat. Peace out and have a great and super awesome day.